Welcome back. In today's video, we will see about permutation and combinations. So in general, it is all about selection and arrangement. For example, if we have 9 numbers, let's say 1 to 9, okay? And we need to arrange this as a 3-digit number. So if we say we are not supposed to repeat the digits, no repetition, okay, and we need to form 3-digit numbers using these digits 1 to 9. So how do we go about it? So we can go and select each one at a time, right? So if you see this box, we can put all 9 numbers. So it is like 9. So after we have selected one, how much will be left? There will be 8 numbers left, right? So in the second box, we can fill it with 8 numbers. Similarly, after filling these two boxes, we'll be left with 7 numbers. So the third number, we can fill it in 7 ways, right? So the total number of ways, that is nothing but the total 3-digit numbers, will be 9 into 8 into 7. So we already saw the factorial representation, right? Factorial of a number. So n factorial, we saw it as 1 into 2 into up to n minus 1 into n, correct? So this here what we are doing, we are arranging the numbers. This is arrangement, right? So what arrangement means is, so if I pick 3 numbers, let's say 1, 2, 4. So now I can shuffle between them. I get 4, 1, 2, 2, 1, 4 like this. So in arrangement, all these 3 are different possibilities, right? But in selection, all these 3 remain same. It is like a set, right? However you write, it will be equivalent. This is equivalent. But in arrangement, this is not equivalent. So now we are seeing about arrangement. So how can we convert this into an elegant formula? What is this again? We have 9 numbers. From this, we are choosing 3 numbers, right? So we represent it like this, 9p3. So for arrangement, we use p for permutation. Permutations mean arrangements. So how do we write this 9 into 8 into 7? So if we try to express this in the form of factorial, then what we'll get, 9 into 8 into 7, we can multiply and divide it by this number, right? 4, 3, 2 into 1 divided by 6 into 5 into 4 into 2 into 1, right? If you see, top one is 9 factorial and bottom one is 6 factorial. But in terms of number 9 and 3, we can write 6 as 9 minus 3 factorial, correct? So this is the formula for arranging R objects or numbers picked from n. So if you have total of n and you're arranging R out of them, then the total number of ways is given by npr, which is n factorial by n minus r factorial. So this is the formula for permutation. Here what matters? Order matters in arrangement. So next again we'll see the simpler version of it, right? Which is selection. So selecting n or objects out of n. So if we take the same example, we saw the total arrangements. Is nothing but n factorial by n minus r whole factorial. But if you take this case, let's say any 3 numbers, 1, 2, 4, as we already saw. In how many ways can we arrange just using these things? So it's like shuffling between these, right? So if I have 4 here, what will I have? I can have with 1 fixed, 2 and 4 I can exchange 4, 2. Then I can bring 2 to the front and shuffle between these two, right? 1, 4, 2, 4, 1. And then I can bring 4 to the front and shuffle between 1 and 2. So in how many ways this is done? It is like equivalent to selecting, ordering, or arranging 3 objects out of 3. So number of ways will be 3 factorial by 3 minus 3 factorial. And this is 0 factorial. 0 factorial is 1. It is just like if one single object is there or no object is there, the number of way of arranging it is actually 1. The emptiness itself is counted as 1. So we get it as 3 factorial. If it is for n objects, so we already chose r objects. So r objects, it will be equal to r factorial. So we need to eliminate these. So we divide by these many number. So this is the initial number, n factorial by n minus r factorial. Now we divide by this much amount to actually cancel these terms, because like r factorial corresponds to one entry. So n factorial by n minus 1 r factorial will corresponds to n factorial by n minus r factorial into r factorial, right? So this is nothing but the selection, number of ways of selecting, and this is given by combination. And this formula is NCR. So selecting r objects out of n is given by n factorial by n minus r factorial into r factorial. Okay, if now we are clear with this, then we can move ahead. So as you can see, simply how this NCR is related to PNR, it's just divided by r factorial, or you can say PNR is nothing but r factorial into NCR. Okay, so then if repetition is allowed, let's say in arranging, then how will it change? Again, n objects we have, and we need to arrange in r places. Again, if we take the example of 3, instead of having 9 into 8 into 7, we have 9 possibilities at each step. So we'll have 9 into 9 into 9, which is 9 cube. So this 3 is nothing but r, equivalent to r, and 9 is the number n. So this is equal to n power r. Okay. So next is when some actions are not exclusive or not mutually exclusive. So mutually exclusive means two events or two or more events that cannot occur simultaneously. For example, if one happens, the other will not happen, right? So for, let's say, event 1 happened, then if this is true, then it implies event 2 cannot happen. For example, if we say sun rises in the east, then it implies sun cannot rise in the west or north or south, right? So that is what it means, mutually exclusive. Not mutually exclusive meaning if one event happened, then the second event also should happen, right? So they are not mutually exclusive. For example, if there are 5 apples and 2 grapes, so number of ways of choosing 2 apples and 1 grape. So this is, let's say if event 1 is number of ways of choosing 2 apples and event 2 is number of ways of choosing 1 grape, since they are related by and, it means both are occurring together, right? So I'll say event 1, number of ways of choosing 2 apples, and event 2, number of ways of choosing 1 grape. So since they are related by and, so both these are occurring together. In that case, the number of ways will be, so number of ways of choosing apple multiplied with number of ways of choosing grape. On the other hand, if they are mutually exclusive, so let's say it's given like number of ways of choosing 2 apple or 1 grape. So this will be given by Na plus Ng. Okay, because it is related by R, which means any one of them is taking place, right? So we can add the possibilities. So this you should keep in mind. This understanding you should be able to get it to solve questions which will be asked in the examination. So next, in the permutation itself, we'll see with identical objects. So initially we said numbers as 1, 2, 3 and until 9, they are all different. If I have say 1, 1, 2, 2 and 3, 3, so they are repeated, right? And then if I have to fill the same box, so how many ways can we do it? So the n here is 6 and r is 3. So number of 3 digits formed from 1, 1, 2, 2 and 3, 3, which is 6 possibilities, and filling in the 3, is it equal to 6p3? It will not be, right? For example, if I choose this one and this one, let's say 1a and 1b, then I can get 1a 2 3, 1b 2 3. So just because I put these tags as a and b, we are able to distinguish these two. But in reality, this tag is not available and they are actually the same number. So we are actually counting this twice, right? So if there are n repetitions of 1, how many ways will this repeat? So we can think of this like this, right? So let's say there is object A repeated some n1 times. So we can say we can choosing 1a from, so again, like it will depend on how much a's are present, right? If there is just one a here, right? So it will just be replacing this a 1 times, which will be equal to n1, right? There will be n1 repetitions. And if suppose there are 2 a's, then it will be like the permutation between these two, correct? Because they are considered as an extra count. So it will be 2p2, which is nothing but 2 factorial. But there are n1 a's, right? So that also we need to count. So this will be this multiplied with n1c2. So we are choosing 2 from these and then permutating it twice. So it will be n1c2 into 2 factorial this way. So in the simplest case, if we have n permutation, npn, that is equal to n factorial. If we have repetitions in this case, so all these a's are coming into picture. So what will it be? So it will be n1c n1 into n1 factorial, correct? And n1c n1, if you substitute in the formula, what will you get? Here I have it. So it is here, right? n1c n1. So it will be n1 factorial by n1 minus n1 factorial into n1 factorial. So if you say this is 0 factorial equal to 1 and n1 factorial cancel, this is 1. Okay. So ncn for any n is equal to 1, and we have 1 into n1 factorial, which will be equal to n1 factorial itself. So we need to divide by so many numbers, right? So it will be n factorial by n1 factorial. If we have some b repeating some n2 times in the same, again it will be like n2 factorial. So this way. So if you have r objects, then it will be n3 factorial, nr factorial. Okay, this way. This will be the number of ways of arranging identical objects. Okay. So there may be something like D, E, F, which are repeated just one time, right? So generalizing the formula, it will be 1 factorial, 1 factorial, but 1 factorial itself is 1. So it's well good enough to say they do not appear in the denominator. And another simple case, if there are n identical objects and number of ways of arranging them in r places. So how much will it be? This be equal to, since they're identical, right? Let's say the object is a, n times, we have n a's, okay, and we have to arrange it in some r places. So if we arrange it, everything will be just a, right? So whatever you select and arrange, it will just be 1. So the number of ways of arranging them in r places, n identical object in r places is 1, given that n is greater than r. So this is always possible, n greater than or equal to r. That is always a constraint. Okay. Next, if you see selection, so number of ways of selecting 0 or more things out of k identical things. So how much is it? So number of ways of selecting 0 things out of k identical things is 1 times. So 1 will be again 1 time. So selecting 2 will be again 1. So like this it will be repeated. This is 0, this is for 0, this for 1, this for 2, until it reaches k. So the total number of ones is k plus 1. So this will be the number of ways of selecting 0 or more. So maximum we can go up to k, right? Because there are k identical things. Okay. So the next thing is number of selections of 0 or more things out of n different things. Okay, so for 0 what will it be? nc0, and for 1 it will be nc1, and so on. We can go up to ncn, correct? If you also see in the other way, we already I think discussed it in the past, in the previous lecture. So if there are n objects, so let's say x1, x2 and xn, selecting 0 or more means for each one I can either decide to select or not select, right? For each one I can decide these both. So for each object there is a possibility of two possibilities, so I need to multiply this. Again, why I am multiplying? They are not mutually exclusive, so that is also called as they are mutually inclusive. So they are mutually inclusive, so I multiply it. How many times it comes? N times. So what will it be equal to? 2 power n. So you can see nc0 plus nc1, ncn is equal to 2 power n. Okay, so this is something important. So instead of 0, if I have number of ways of selecting one or more things, then what will I have? nc1 plus nc2 up to ncn, right? So other way of seeing it is you just need to shift this to other side. This is nothing but 2 power n minus nc0. nc0 we already saw. So ncn is equal to nc0 is equal to 1 for any n. So this is 2 power n minus 1. So to visualize it this way, right? It is same as selecting all objects, but one possibility which is not selecting any of them. That is one possibility. So we need to remove that because we need at least one thing to be selected, right? So we are excluding that possibility and we arrive at 2 power n minus 1. And this is one important thing. And other thing, if you see, NCR is equal to NCn minus r, right? So what is NCR? N factorial by n minus r factorial into r factorial. What is NCn minus r? N factorial by n minus of n minus r whole factorial into n minus r factorial. So n minus n plus r, this is right. So n cancels, we get n factorial by r factorial into n minus r factorial. So if you see, these both are equal. This is because of the symmetry in the denominator, right, between n minus r and r. So this is possible. So as a corollary of this, if I have m plus ncn, then this will be equal to m plus nc, m plus n minus n. So n cancels, which is m plus ncm. So if you have sum of the numbers in the as the total number, then number of ways of picking one, let's say n of them, and number of ways of selecting the remaining of them are equal. To visualize this, it is like saying number of ways of selecting n of them is same as number of ways of leaving out m of them, correct? So that way, if you visualize, they both are equal, right? They both are like sentence wise and mathematically also they are equal. So like this, with combination formula itself, we can have many different things, different equations coming out. So for as another example, we have NCR plus NCR minus 1. So in this case, what happens is the top number x like increases by 1 and the r remains same. So if we just write it out, we have n factorial by n minus r factorial into r factorial plus n factorial by n minus r minus 1 factorial into r minus 1 factorial. Sorry, this is r plus 1, right? So if we just write it out, so this is, let's keep this same because we want r, right? So n minus r factorial plus, so this we can multiply and divide by r. So what will we get? So here I can remove n minus r plus 1 into n minus r factorial, and this will become r factorial. So now if I just write it out, what will I get? N minus r1 plus 1 into n factorial plus n factorial into r divided by n minus r plus 1 into n minus r factorial. So this factorial into r factorial. So if n factorial is common here, right? So if I just take this out, see r and r cancel, then we have n plus 1 and n factorial, which is n plus 1 factorial in the numerator. Denominator, this 1 I can bring this side. So n plus 1 minus r factorial into r factorial. But this is nothing but equal to RHS, right? N plus 1 CR. And this is also some important formula which might come useful. But if you know just the basic, the formula, you will be able to solve most of the questions. So next we will see about circular permutations. So this is number of ways of arranging things in a circular order. So in linear order we saw, so if 3 things are there, and if you want to arrange 3 things, then it is like 3 factorial, right? Let's say A, B, C. So what are the 3 factorial is 6, 3 into 2 into 1. So what are the different ways? A, B, C, A, C, B, and then B at the start. B, A, C, B, C, A, and C at the start. So C, A, B, C, B, A, correct? But in the circular thing, if you see, if I have A, B, C, this is one possibility. And if I just try to invert them, C and B, so this is one possibility, A, C, B. And I can just switch this. If I try to switch this, sorry, B and A, so B, C, A. So do you notice something weird here? So I'll again write out A, B, C, right? If you see here also it is A, B, C, right? So to the right of, let's say all are facing inward, to the right of A I have B, and to the right of B I have C, and to the right of C I have A. Here what I have, to the right of A I have B, to the right of B I have C, and to the right of C I have A. So these both are same, correct? So why this is happening? This is happening because in the linear arrangement the ends are different. So A and C at the end and C and A at the end are different. But in this case it is like the same. So the ends are meeting together. So few of the options in the linear is just repeating. So how do I reduce from here to here? Correct? So this again is not the correct thing. So if I have ABC, then what and all I can't have? I can't have ABC and BCA. This also I can't have. And CAB. This also I can't have. Correct? BCA and CAB. So and again for ACB, what all I can't have? I can't have ACB. CBA I can't have. And BAC also I can't have. So there are only 2 possibilities for a circular thing. So in general, if you have n objects sitting, so how do we write? We know the total permutation is n factorial, right, for a linear arrangement. So how do we reduce from this to this? If you see, if I just keep A, B, C like this n times and just shift this places like this, let A sit in the B's place, B sit in the C's place. So I just ask them to push once to the right side or left side, right? Left side of each person. Then like this, how many ways I can go? If you see here, if I try to push, A will come here for one push. Then for the second push, A will come here. And for the third push, A will come here, right? So I can have like 3 possibilities for 3 cases. For n cases, how many possibilities I can have? N possibilities. So this n is the number that is repeating. So what I do, I just divide it by n. Then what I will get? N minus 1 factorial. So the number of ways of arranging n objects in a circle. What is this? This is n minus 1 factorial. If you see for this case, it's 3 factorial by 3, which is 2. 2 factorial, which is nothing but 2 itself. So we have 2, right? Okay. So in this case we also consider, so ABC is not same as ACB, right? So what we had considered here, clockwise and anti-clockwise observations are different. Then we got it as n minus 1 factorial. If they are same, like if there is no difference between left and right, then how much we'll get? We need to just divide by 2, because for every left there will be one right. So it is n minus 1 factorial by 2. Simple only. So the next is, if I have n things, 1 2 3 4 and so on, and n, and if I have to choose k consecutive things, for example, I can choose from 1 to k, 1 to k, then from 2 to k plus 1, and from 3 to k plus 2, and so on, right? And at some place I'll get some r to n, then the next place I'll get r plus 1 to 1, correct? So like this it will repeat, correct? So I'll take a simple case we can take with 3, 1 2 3, and if I have to take two consecutive things, so what I can do, 1 to 2, this is 1, 2 to 3, this is 2, and 3 to 1, this is 3, and this again is repeating, so I can have 3. So 3 is nothing but, okay, if we are still not sure, we can go to the case of 4, 1 2 3 4. So 1 to 2 is 1, 2 to 3 is 1, 3 to 4 is 1, 4 to 1 is 1, then again it repeats. So you can see now it is equal to 4. So for k consecutive things out of n, if it is equal to n, right? If k is strictly less than n, if it is equal to n, let's say 4, choosing 4 people, then it is just one circle. Then actually it is the same set of people, right? 2 3 4 1 is same only. So if it is equal to k is less than n, then it is equal to n. If k is equal to n, then it is 1. Why? Because it is selection, right? So in selection 1 2 3 4 is same as 2 3 4 1. That's why this count is reducing. If it is less than n, then what it will be? It will be 1 2 3, then 2 3 4, then 3 4 1. You can see all these are different things, right? Different collections. And 4 1 2, all these are different collections. So that's the catch. So this is all with permutation and combination. In the next lecture we will try to solve some questions on this. So solving question, like, it will be little more different from theory, right? So theory will not always, just knowing the theory will not help you to solve the questions as well. So there are some minute tricks and tips to solve questions as well. So that we'll see it in the next lecture.